Alright, welcome back. I'm going to do a problem from section 1.3. This is an application, problem 95. I've got it here on my phone. Hopefully you can read that. It says an open box is to be constructed from a square piece of sheet metal by removing a square of side 1 foot from each corner and turning up the edges. If the box is to hold 4 cubic feet, what should be the dimensions of the sheet metal? Alright, so I'm going to start off here by drawing a picture. And it's a square, right? Constructed from a square piece of sheet metal. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, we don't know how wide it is, right? But it's a square, so we'll call them all x. And the question is, what should be the dimensions of the sheet metal? But it does say we're cutting a 1 foot from each corner. So obviously x has to be more than 2, right? Because if you cut out a foot over here and you cut out a foot over here, well, that's 2 feet. So it's going to look something like this. So let's say that's let's see, 1 foot. So that's 1 foot, and that's 1 foot. And we'll do the same thing over here. Should probably do it. A little more intuitive would be just to use 1. So we'll do 1 here. And we're going to cut that square out. We're going to cut this square out. I'm going to cut this one and this one. Alright, these are all 1. Alright, and when we do, when those are gone, it's going to look, like this, right? So those are going to be cut away. Right. So remember now, from here to here was x, right? But we cut out 1 foot, and we cut out 1 foot each way. So really, this is going to be x minus 2. This part from here to here is going to be x minus 2, isn't it? Alright, and then we're going to fold it along these edges right here. It's going to make a pan. Right? So we're going to fold those sides up and make it like an open top box. So those get folded in. And our final product, I guess, will look something like this, right? We'll have, this will be the side view, and then it will, like, something like that, right? So you can hopefully see in there a little bit. And it says that if the box is to hold 4 cubic feet, what should be the dimensions of the sheet metal? Well, it's going to hold, that's volume, right? And we know that volume of a box is what? Base times height times width, right? So it's how wide it is, how tall it is, how deep it is. So let's look at the dimensions. What would the dimensions of this be? Well, looking over here, since we cut out a square size 1 foot, when I fold that up, that's going to be this right here. So that's 1. And this is the width, and this is like the other dimension, like the depth of it, I guess you'd say, right? Length and width or something. And those are both going to be, well, if this is x and you cut out a foot here and you cut out a foot here, that leaves you with x minus 2. So this is x minus 2 and this is x minus 2 right here. So now we have the dimensions of the box. And the volume has to come out to be 4 cubic feet, right? So that's got to be 4. So 4 equals, let's make that length. Instead of base, we'll use length, width, and height. So the length is x minus 2. And the width is x minus 2. And the height is 1. And the 1 really doesn't do much of anything, does it? Right? It's just when you multiply by 1, so I could just not worry about it. So really it's just 4 equals x minus 2 squared. And now if I solve it, oh wait, yeah, that's right. So if I solve it, I can take the square root of both sides, and that gives me x minus 2, and let's see, if I take the square root of this side, I get plus or minus 2, positive and negative 2, right? 2 answers. So it's x minus 2 equals 2 and x minus 2 equals negative 2. So it's x equals 4 or x equals 0. Obviously it can't be x equals 0, so it must be x equals 4. Alright, now let's see, it says it's 4 feet by 4 feet. Yeah, so that's got to be it. So that's 4 feet. Done. So that's an example of a folding up a box. Now the next one says rework problem 95 if the piece of sheet metal is a rectangle whose length is twice its width. Whose length is twice its width. So if we rework it, so let's let this be the width, and its length, that's twice that, so that's 3, 1, 2, 3, 4, 5, 6. So that's W, and whatever this is twice that, right? So that's 2W and that's 2W. So its length is twice its width. Now you're still going to cut out this square, right? And I guess everything else is the same, so it's a 1, right? These are each 1. And when you fold it up, the only difference is going to be you still have volume equals length times width times height. And it's still going to be 4. But the length is going to be 2W minus 2, right? Because the bottom of the box, as you can see, is going to be this little part right here. And this length right here is what W take away 2, because we cut out a foot over here and a foot over here. And this bottom part is going to be 2W minus 2. So it's W minus 2 times 2W minus 2. Alright, so now we just need to work that out. So let's see. 4 equals W minus 2. I'm going to just pull a 2 out of here. And that's going to be W minus 1. So I factored a 2 out. And now I can divide both sides by 2, right? So that divide that side by 2, it goes away, divide this. So that's 2 equals W minus 2 times W minus 1. Alright, so I'll distribute. So 2 equals W times W is W squared minus W minus 2W. Oh gosh, I'm off the page. Sorry about that. So W squared minus W minus 2W plus 2. Alright. So let me go back over in case you didn't see what I just did. So length, that's the volume's 4. And we find the volume by doing length times width times height. The length is W minus 2. The width is 2W minus 2. The height is 1. And it just, it doesn't do anything, because when you multiply by 1 you get the same thing. Then I factored a 2 out of this, so I pulled the 2 out, leaving behind W minus 1. So now I still have W minus 2 times W minus 1. Then I got rid of the 2 by dividing both sides by 2, right? So divide this side by 2, it goes away. Divide this side by 2, you get 2. So now I'm down to W minus 2 and W minus 1. And now I just distributed. Alright, so 2 equals what? W squared minus 3W plus 2. Right, and what do I do? It looks like I can take away 2 here to make that 0. So 0 equals W squared minus 3W. And now I can factor out a W. So 0 equals W times W minus 3. So our two solutions are W equals 0 and W minus 3 equals 0. So W is 3. So the width would have to be 3 feet. Therefore, the if this is 3, then this is going to be 6. Just so happens that's the dimensions I drew it. Got lucky. Alright, and that's it. We'll work some more problems in class on this. Thanks for watching.